Alright, last concept guide of the quarter, of the semester. 4748, solving systems of equations with matrices. Solving systems of equations with matrices. Each square matrix has an identity matrix such that when it's multiplied by another matrix, you get the same matrix. Remember multiplicative inverses? Alright, whenever you multiply a number by its reciprocal, you get 1. Well, multiplying by an inverse is basically the same thing. Most matrices have inverse matrices such that when a matrix is multiplied by its inverse, the product is an identity matrix. We've talked about that a little bit, but the identity matrix is when you get 1, 0, 0, 1. You get that diagonal 1 going across. Well, the matrix 3, 1, 5, 2, its inverse is right next to it. It's 2, 3, negative 1, and 5. As you can see in the green box, the 3 and 2 have been flipped in the red box, and then the 1 and the 5 have been multiplied by negative 1. To the left, I wrote that down. You see m to the negative first power. Anything to the negative first power is the inverse of that. Alright, so if I multiply those two matrices, just like we've always done in multiplication, get 3 times 2 is 6, 1 times negative 5 is negative 5, then first row times second column, second row times first column, second row times second column, I would get 1, 0, 0, 1. That is an identity matrix. Another example, they can get bigger and bigger. A 3 by 3, the identity matrix, if you look up here, up top, would be 1, 0, 0, 0, 1, 0, 0, 0, 1. Just be that diagonal 1 going across the matrix. That's an identity matrix. Alright, our formula to get an inverse without using the calculator is 1 over the determinant times, flip A and D, and then multiply B and C by negative 1. We'll get more into that. I want you to know how to use that formula, but we're going to do most of this in the calculator. Alright, so to do in the calculator, you need to learn how to break down a system of equations into a matrix equation. To do that, you're going to take the coefficients, 5, negative 6, 3, and 2, make that a matrix. Then you'll multiply it by a matrix of your two variables, x over y. The first variable is always on top, and then the variable below is the second one, or it's alphabetical, right? And then that equals a matrix of what the two equations equal. Right, B, again, if I set that up into a matrix equation, got that there. I've got my coefficient matrix, my variable matrix, and my solution matrix. Alright, so next I'm going to walk through how to use your calculator to solve these equations by using matrix equations. Alright, so right there, as you can see, this is for A, the question A. If I made an matrix A, this would be A right here. I'd put that in my calculator, okay? As a 2 by 2, make that A. Then I would make what my matrix equation equals as B in my calculator. And I'll do the inverse of A times B, and it'll give me my solution. That's the same solution you'd get if you graphed, substitution, elimination, Kramer's rule, any of that. You're obviously going to get the same solution. That's the point of intersection of those two lines. Alright, so let me go real quick to what a calculator would look like. Alright, so again, to do that, you would hit second and then matrix, and that would take you to this screen. You'd want to edit it, make a 2 by 2, put in your coefficients, then you'd want to make B remember rows by columns, so you'd want to make this a 2 by 1 and make that your solution matrix. Once you make those, you will go to your home screen and you'll hit second matrix again. You'll press enter on A, and when you press enter on A, it will bring it to your home screen like that. Alright, then you, without hitting second, do not hit second, you will hit your matrix button again. So you can see that's x to the negative first power. Alright? Raising anything to the negative first power gives you its inverse. So raise that to the negative first power, and then you'll multiply that by what you made with B, your solution matrix, and that will give you your answer. Okay. So again, you'll do the same thing for B. You'll make that A, you'll make that B, plug them into your calculator, and then find the inverse of A times B, and you'll get your solution. Okay. Same thing. Oh, this next section is just a review section. As you can see below, it's adding, scalar multiplication, finding the determinant, multiplying. This is just review. If you want to look over this and review it, press pause, write this down, make sure you still know how to do it for the Chapter 4 test coming up. Alright. Last page. Alright, I got 3 by 3 matrices. Well, you're going to want to set them up the same way. You've got your coefficient matrix, your exponent matrix, and what it equals. So again, you'll set this up in your calculator, and you will make this matrix A, this matrix B, find the inverse of A, and multiply it by B, and that's what you'll get. So in your calculator, it should look like A to the negative first power times B, and it will give you that right there in your calculator. Do the same thing for the next example. Set up your matrix equation. You'll do the inverse of A times B, and that will be your solution. You remember, this is A, this is B. Alright, not too hard, you just got to make sure you know how to use your calculator properly. We'll go over it more next class. Don't forget to turn in your Kramer's rule sheet if you haven't done that yet. Okay? Alright, you'll have a good day.